video, I'm going to explain about block diagram reduction techniques and a simple problem on block diagram reduction topic. So we see that what are the techniques, what are the rules we have in block diagram reduction technique. So the block diagram can be reduced to find the overall transfer function. So this is the main application of block diagram. So we have to be uh, bring that a complex system, the block diagram to the single transfer function. So for this, we are going to be use that different block diagram rules. The following rules can be used for block diagram reduction. The rules are framed such that any modifications made on the diagram does not alter the input-output relation. So by simplifying different modifications in the block diagram, finally we obtain that transfer function of a given system. We'll see that one by one, what are the rules we can follow to reduce the block diagram in block diagram reduction technique. The rule one, combining the blocks in cascade. So if two blocks are in connected in cascade, we can change this diagram to here. So here G1, G2 are in cascade, right? So the cascade elements we can multiply to each other, then finally we'll get final one block G1 with G2. Rule number two. So combining parallel blocks or combining feed forward paths. So if two blocks are connected in parallel, so how we can identify the parallel means the two signals are starting from one point and ending at one point. So then only we can say that two blocks are connected in parallel. See here, G1, G2 are connected in parallel. So here the signal is going from here. So for both blocks, and these two blocks are ended at this summing point. So we'll say that after eliminating these parallel blocks, we will get G1 plus G2 because both having the positive sign, right? So we'll have G1 plus G2. Suppose if it is having the negative sign, then we'll get G1 minus G2. So whatever modification we done, but it is not disturb that input-output relation. Before eliminating the parallel blocks, whatever we have this diagram, so we'll get the output A into G1 plus G2. After elimination of these parallel blocks, we are getting the same output A into G1 plus G2. Next, come to the rule 3. Moving the branch point ahead of the block. So this is the branch point. It is in the position. If you moving the from here to here, we'll see that what is happening in this. So here for this one, it is having that one. Let's consider it is a one. Whatever it is signal is here coming here, the same output you will get here. So this is multiplied with one. Where the branch point moving ahead of the block, this line, this path, we have the gain 1 by G. So this is the diagram after moving this branch point from here to here. We get the gain is 1 by G. Whatever modification is done, the same output we are getting here. So here AG, here A, and the same output AG and A. So just we modified that, we just modified the diagram by moving the branch point from one point to another. That is ahead of the block. Now let's see the rule number 4, moving the branch point before the block. That is, we have to be bring this moving of branch point that is backwards to the path. See here, this is the branch point in this position, so we have to be bring this branch point from here to here, that is before the block. Now here the gain value is 1. When it is moving from here to here, that is before the block, that value is changed to G. So we'll get the same output AG and AG. Now rule number 5, moving the summing point ahead of the block. So up to now we see that the branch point moving ahead and before. Now we'll see that summing point. So the summing point is available here. We have to move this summing point ahead of the block G. Now here the gain is 1. When it is moving from here to here, the gain was changes to G. Final output is G into A plus B. So here also we are getting that G into A plus B. So this is rule number 5. Next, rule number 6, moving the summing point before the block. So here the summing point is there. We have to move this here to here. So the gain is 1. So what will happen if it is moving before the block? So it is happening that it have the 1 by j as a gain after moving off summing point from here to here. So finally we get the same answer, AG plus B. Next, rule number 7, interchanging the summing point. So we have to interchange the summing point even though there is no changes in input and output relation. So this is the summing point 1, summing point 2. Here the summing point 1 having that A plus B signals, and summing point 2 we have A plus B, and C finally we get A plus B minus C. Now if you interchange this two summing points, you'll see that so the summing point this one will bring here, and this one is bring here. So first we have to be seen that only the signals which is connected to the summing point and its sign. See here, A, B are connected this summing point with the addition sign. Here, this combination is having the with the addition with C with having the negative sign. If you interchange, this is the summing point modifications, and finally we'll get A plus B minus C. So same output before and after moving interchanging the summing point. Next, splitting the summing point. So a summing point is can add three inputs and one output. If you want to splitting this, we have to splitting the summing point to simplify the block diagram reduction. So here A, B, C, these three signals are adding with the one summing point with the symbols of plus, plus, minus. We have to splitting the summing point to 2, 2. So this is the way of splitting the summing point when it is having the more than one signals, or so more than two signals, sorry. So this is the way we can splitting the summing point. Next, combining the summing point. This is if a diagram having the two summing points, we can bring to the one summing point, then we can reduce that diagram. So this is the way we can combining the summing points. Next, rule number 10, eliminating the negative feedback loop. So if a system having the feedback loop, first we need to be identify that the feedback is belongs to the positive or negative. How we can identify means by the negatives, by the sign of this feedback. If it is indicated by the negative sign, then we can call it as negative feedback loop. If it is indicated by the positive sign, then we can say it is a positive feedback loop. So here, this is the diagram represents that negative feedback loop. So here G is forward path gain and H is feedback gain. So R and C are input and output. Now, by simplifying this equation, we are getting the transfer function C by R is equals to G divided by 1 plus GH. This equation we obtained by solving this simple modification. Now, rule number 11, elimination of positive feedback loop. So here, the feedback is added to the positive sign. That's why it is called as positive feedback loop. And its transfer function, we can write G divided by 1 minus GH. So these are the 11 rules we need to be followed while the reduction of block diagram. And these rules is not mandatory to apply every diagram. Some rules are needed to apply, some rules are not no need to be applied, but we have to be clarity that which rule is applicable first and which rule is applicable next, because the diagram has to be reduced to transfer function with as soon as possible. If any did the mistake, if any mismatching in the application of rules, will get a lengthy problem. So first we need to be identify that which rule we have to be applied firstly. So let me see a simple problem on block diagram, and by using these 11 rules, how we can bring that block diagram to transfer function, right? So this is the a simple block diagram we have, and from this we are going to be find the transfer function that is already mentioned C by R by using block diagram reduction techniques. So here first we need to be see that what how the block diagram and what are the blocks are connected in cascade and connected in parallel. So we'll see that one by one, rule number from rule number 1 to rule number 11. So first rule number 1 is uh, cascaded blocks. See here, this there in here there is no blocks are connected in cascade because G1, G2 having the same path, but in between there is a branch. So if you want to make this two G1, G2 blocks or cascade, we had to be eliminate this branch point, either moving ahead or before. So let me see the one by one. First, so I'm going to be, so this is the block diagram we have. First, I'm going to be move this branch point ahead of G1. The reason is if you moving this here to here, then we have the feedback loop. Then we can easily simplify that. Or else, if you moving this branch point here to here, then we'll get the cascaded and feed forward. After that, again we have to be moving. So one more steps is additionally added when you moving this branch point. So now we have to move this branch point from here to here. So we can place this branch point here because if it is placed here means it is not possible to eliminate the feedback. So that's why we have to move this branch point from here to here. We'll see that what will happen. Move the branch point ahead of block G1, then the above figure becomes. So I'm moving this branch point 1 here to here. Already it has the gain value G3. If it is moving ahead of G1, the gain value additionally added with 1 by G1. Already we discussed in the rules. So this is the gain value of this path modified after moving this branch point from here to here. Now we have the feedback loop and we have to eliminate this feedback loop. So it is a negative feedback loop. It is identified by sign. So we have to eliminate this block by using the formula. Already we know, right? So for this transfer function, you will get G1 divided by 1 plus G1 into H. This is the term. And these three blocks. So first we will see that these two blocks are on cascade. So the cascade elements we can have to be multiplied. So we'll get G3 divided by G1 and G2. So this cascaded combination in parallel with G2. So we have to be add G2 plus G3 divided by G1. So this is the blocks after elimination of feedback loop and feed forward paths. Now these two are connected in cascade, so we have to multiply these two terms. So finally output is equals to input into these two terms. G1 get cancelled. So finally C by R is equals to G1 G2 plus G3 divided by 1 plus G1H. First clarification, we can observe that the denominator terms which is including that feedbacks. So in this given diagram, we have the one feedback that is H with respect to only G1. So whatever we have the feedback with respect to the block, that is comes in denominator, that is 1 plus J1H. And numerator is reference that how the path is going from input to output. So we have the two paths. One is from G1 input to from input G1 G2 to output. One path is input G3 and output. So here, see here, one path is input flowing through G1 G2 and output, and the second path is input and going to from G3 to output. So we have the two paths, right? So the numerator term is represents that forward path from input to output. The denominator terms we can represent, we can have that based on the feedback. So in this block diagram, we have the one feedback that is with respect to the G1. That's why that is our negative feedback, right? So 1 plus, we have 1 plus G1H. So this is the transfer function for the given block diagram. Right. This is the way we can reduce the block diagram by using block diagram technique rules. So thank you.